Hello and welcome to another exam paper walkthrough. We're going to be doing a past paper today. We're doing it with a live studio audience, which is quite novel. So we've got a group of about 20 Year 11 students doing this alongside me. We're going to be looking at the Edexcel November 2020 series, so quite a recent series. And we're going to be looking at their 3F papers, so the calculator papers. In the description to this video, you will find a Google Drive link that will take you to a downloadable copy of this paper. I'd strongly recommend you've either already done the paper or you do it alongside the video. If you find this useful, please subscribe if you like. Okay, before we get really into the video, I should really do this more often. If you're picking up a calculator that's not yours, you always need to make sure that it's in degree mode and also that you've got this natural display on. So if you want to reset your calculator, the pattern that you would need to press is Shift and then 9, which you've got reset written above the 9 button. It gives you what you want to reset. We want to reset all, say 3, and then you just press equals. And then that will make sure that a couple of things happen. Firstly, that you'll have a natural display, so you'll be able to type in fractions correctly. And secondly, it'll put your calculator into degrees mode. I see it every year, and it's even written in some mark schemes. Your answers always need to be in degrees. So if any questions like the trig question, your calculator is not in degrees mode, you will often get a miscalculation. You'll get it in terms of gradients or in terms of radians. So you always need to make sure it's in a D mode. So again, that pattern, Shift 9 on these calculators, and then equals, then 3, initialize all, reset yes. And there we go, calculator reset. Okay, so I'll just shrink my calculator down a bit. Right, question 1. Change 300 centimeters into meters. If you really can't do this, you can use your calculator, but you're dividing by 1,000. You're dividing by 100. So 100 centimeters is 1 meter. So 300 centimeters would be 3 meters. Okay, question 2. Work out 1/3 of 24. Again, on your calculator, you could do it as 24 times by 1/3 if you wanted to, or in your head, 24 divided by 3. Either way, we get 8. 40% as a fraction, it would be 40 over 100, and again you can use your calculator if you're not confident cancelling down fractions. It will do it for you. 40 over 100, and your calculator will automatically cancel it down to 2/5. For question 4, work out 2.5 to the power 2, so calculate 2.5 to the power, or just squared. Gives you 24 over 4. 25 over 4 would be absolutely fine as your answer. You could do it as mixed fraction, Shift, and then that fraction button, 6 1/4. That would also be fine. Okay, question 5. Write the following numbers in order of size, starting with the smallest. So smallest number here is -6. Then we've got, -4, -3. Those are all my negative numbers. Then we've got 0, 1, 2, 7. Okay, question 6. This graph shows some information about car production in the UK over 8 years. How many of these years does the car produce more than 1.4 million? So 1.4 million would in effect be this line here. So we've got 1, 2, 3, 4, 5 years. Part B, in which 2 years was the production the same? So I've got to try and find totals that are the same. That's year 5 and year 6. And question 7, what fraction of the shape is shaded? Give your answer in the simplest form. So we've got a 4 by 4, so it's going to be out of 16. We could count all the numbers that are shaded, save myself a bit of brain power. I'm just going to say we've got 4 unshaded, so that must mean that we've got 12 shaded. And then again, you can use your calculator to simplify this if you're unconfident with simplifying fractions. 3 over 4. Okay, question 8. Karen buys 200 tiles. The tiles are sold in boxes. There are 25 tiles in each box. Each box costs £9.75. Work out the total cost of boxes. So we need to do 200 divided by 25, and then we need to times our answer by 9.75. I wouldn't do any stages to that. I'd type it in like that and use my calculator. So 200 divided by 25, and then I want to times my answer by 9.75, giving me 78. Okay, question 9. Work out the value of 300 divided by 2 times 5. Again, I wouldn't do anything other than type that into my calculator. So 300 divided by 2 times 5. Only 1 mark for this question, so it's just 1 mark for the answer. So I wouldn't do anything more complicated than that. Work out the value of, and again, calculator can do this. So 6 minus 2.5, close brackets, times by 8 plus 4. Make sure you've typed it in right and put a multiplication between them, and then your calculator will do that for you. 42. Write down the reciprocal of 20. Again, your calculator can do this for you. I'm sure that you're all more than capable of doing it, but if you do 20, and then this is the reciprocal button, that's the reciprocal button, so your calculator will automatically do it for you, 1 over 20. Okay, and on to question 10. The graph shows information about time in minutes a liquid has been cooling and the temperature in degrees C. Write down the temperature of the liquid after 2 minutes of time. So 2 minutes of time, we go up to our graph and we read across. So it's hitting at 80. So after 2 minutes, the temperature would be 80 degrees. Part B. Pam records the time when the liquid had a temperature of 50 degrees C. Write down this time. So I changed pen colour. So we're just looking at 50. We go across. You're obviously going to do it with a ruler and read down. So we're looking at 8 minutes. And then part C. Pam says the temperature in the liquid drops more in the first 3 minutes of cooling than it does between 9 and 12 minutes. If Pam correct. So the first 3 minutes of cooling. In the first 3 minutes of cooling, it's dropped by roughly from 200 to 72. So it's dropped roughly 28 degrees. Okay, so in the first 3 minutes, it's cooled by 28 degrees. In the time between 9 and 12 minutes, we'll just look at how much it's cooled. Between 9 and 12, it has cooled by roughly, I think, 6 degrees. So is she correct? Yes, she is. Yes, and you can quote the figures. In first 3, it cools by 28 degrees. In 9 to 12, it cools by 8 degrees. That's absolutely fine. You could also state, if you wanted to be a bit more technical about it, you could say the gradient of the curve is steeper between 0 and 3 than it is between 9 and 12. Both of those are absolutely fine. Okay, question 11. So we've got quadrilateral, work out the size of y. To work out the size of y, we need to work out the size of this angle here. I'm going to call that x to start with. So I'm going to do 360 minus and then add the 3 known angles, so 95 plus 130 plus 65 is equal to. So it doesn't ask for reasons, but I've kind of made it clear what I'm going to do. And again, it wouldn't do anything other than type that into my calculator. So that angle X is going to be 70. So Y is going to be equal to 180 minus that, because angles in a straight line add up to 180. So we're looking at 110. Okay, question 12. Here are a list of 5 terms of a sequence. Write down the next 2 terms of the sequence. So we're dropping by 5 each time. So the next one would be 20, and then the next one would be 15. In a term of this sequence is minus 5. Which term? So if I was looking at this, I could carry the sequence on until I got to minus 5. It wouldn't be too much legwork. However, if it's going down by 5 each time, it means that there must be a 5n at the start of the sequence. To get from minus 5 to 45, I'd need to add 50. And we know that, or we want to find what the value of n when that is equal to minus 5. So if I rearrange by adding 5 onto both sides, I'm going to add 5n onto both sides first of all. So 50 is going to be equal to 5n minus 5. Add 5 onto both sides, 55 is going to be equal to 5n. Divide both sides by 5, 11 is going to be equal to n. So n is going to be equal to 11, so it's the 11th term. The nth term of a different sequence is given by the expression 4n plus 3. Find the 9th term. So we just do 4 times by 9 plus 3. And again, you don't need to do anything other than type that into your calculator. You are more than capable of doing it in your head, but double check it. 39. Most straightforward way. Okay, question 12. Work out the perimeter of this shape. So we've got a couple of dimensions that we don't know at the moment. Perimeter's all the way around the outside. It's an awkward one. There is a mathematical argument that I could give you about that. I don't need to work these sides out, but I won't at this point. So just looking at it, if this side's 7 and this side is 5, this side must be 2. If this side is 10 and this side is 6, this side must be 4. So in effect, I now need to work out the perimeter of the whole shape. I could take a shortcut and say that it's going to be 2 lots of 7 plus 10. Sorry, 2 lots of 7 plus 10, which is going to be 2 times by 17, so 34. Alternatively, and the more common version though, is to work out the total by adding them all together. So to do 4 plus 5 plus 6 plus 2 plus 10 plus 7. But if you think about it, we've got a 7 there and then a 7 there. We've got a 10 there and then a 10 there, which is why it's 2 lots of that. Either way, you get 34. Okay, question 14, simplify. So to simplify this, we're looking at collecting like terms. So we can collect our x's together. So 3x plus 2x would give us 5x. And then we look at our y's. So plus 5y minus 4y would give us just y. So plus y. So 5x plus y. For the next one, solve. I'm going to minus 7 from both sides as my starting point, so that would give me 5p is equal to 15. Then divide both sides by 5. That would give me p is equal to 3. So p is equal to 3. Okay, question 15. Here are the costs of the same type of batteries at 2 shops. Shop A, packs of 4 batteries for £1.60. Shop B, packs of 6 batteries for £2.60. Harry needs to buy at least 30 batteries. He assumes that he has to buy batteries in whole packs. Harry wants to buy the batteries as cheaply as possible from the same shop, so we can't do a combination. Which shop should he buy the batteries from, shop A or shop B? Okay, so I'm going to start by looking at shop A, and I'm going to see how many packs he would need to buy. If he wants to get at least 30, he would need to buy... 30 divided by 4 is going to be 7.5, so you would need to buy 8 batteries or 8 packs of batteries from that shop. And then for the second one, for shop B, Batteries come in packs of 30. Packs of 6. So we would need to buy 5 packs from this shop. Right, so that's how many packs. Now if we look at the prices, so 8 times by 1.6, and then we're also going to do 5 times by £2.70 or 2.7. So now I go to my calculator. 8 times by 1.6 gives me £12.80, and then 5 times by 2.7 gives me £13.50. So I'm just checking my figures here. Yeah. So which shop should he buy the batteries from, A or shop B? So we're going to go, should buy from shop A. Shop A is cheaper. Plus, you'd actually get two extra batteries. Plus 2 extra. So it's cheaper in price, and you will get 2 extra batteries. How his assumption is wrong. He can buy single batteries for 40 pence each from shop A and 45 pence from shop B. Does this affect which of the 2 battery shops he should buy from? No, he should still, because shop A is still cheaper, even if what we're saying now is he can buy it even cheaper from shop A. So does that affect my answer? No, shop A would be even cheaper. So won't affect. Because the question was actually which shop should he buy from, so our answer won't change. The price he would pay would change, but it would still be cheaper. Okay, question 16. There are only 5 blue cards, 2 green cards, 4 red cards in a pack. Isabella is going to take at random 1 card from the pack. Write down the probability that Isabella takes a blue card. So we've got 5 blue cards out of the total number of cards, which would be 5 plus 2 plus 4. So it's going to be 5 out of, use your calculator if you want to, but 5 out of 11. Ken is going to throw a biased dice once. The probability that the dice will land on a 6 is 0.3. What is the probability that it will not land on a 6? So 1 minus 0.3. Again, use your calculator if you want to, but 0.7 is what we're looking for. Okay, question 17. Draw an accurate isosceles triangle with sides of 8 centimeters, 6 centimeters, and 6 centimeters. One of the sides has been drawn for you. So I'm going to struggle with this one slightly to show you. In effect, what I want to do is get a set of compass arms. So hold on a second. So to describe this, I'm going to set my compass. I'm going to lay down my ruler. I'm going to set my compass arms to 6 centimeters. So I'm going to set my compass arms using my ruler. I'm going to set my compass arms to 6 centimeters. Once they're at 6 centimeters, I'm going to place my compass point here, and then I'm going to do an arc into the center. I'm going to keep my compass arms the same distance apart and do the same from the other side. And then the point where the 2 lines meet becomes the top vertice of the triangle. So I'd need a compass for this. I can't really display that very well, but that's the method that I would use. Set my compass arms to 6 centimeters, place the compass point at the end of the line and arc into the center. Do the same from the other side. Where the 2 arcs cross will become my top point of my triangle. Yeah, when you're drawing this, you do need to show these what we call construction lines. To pick up all the marks, you do need to show your construction lines. You can't just kind of measure it. Okay, question 18 then. So this graph can be used to change between US dollars and British pounds. So we've got US dollars, British pounds. Rosie brought a ring in the USA. She paid $345 for it. Work out how many pounds she paid for the ring. So we can't do that as an accurate conversion. If we look, what we've got is our US dollars only goes up to 70. So 345 we're going to struggle with slightly. So what I'm actually going to do is I'm going to find 35. So 35 US dollars is going to be equal to, so if I go 35, go across to my graph, and then read down, is just over £25. So we're looking roughly sort of £26. So 350 times by 10 is going to be equal to 260. So that's how I would do my conversion. So I would say 260. So how you've gone about that is slightly up to you. I think that works best, in my opinion. The answer says that we can accept anything between 258 up to 275. So yeah, that process is what we call extrapolation. So using a conversion graph to go further with data than is shown. Right, question 19. There are types of sandwiches sold in a cafe. 56 tuna sandwiches were sold. This was 40% of the total number of sandwiches sold. Work out the total number of sandwiches sold. So in effect, it is saying that the number of sandwiches sold, we'll call it X, times by 0.4, that's 40%, is equal to 56. So if we want to work out the number of sandwiches sold, we'd do 56 divided by 0.4. So there are going to be 140 sandwiches sold. 56 of the tuna sandwiches are sold. 18 were sold on Friday. Write 18 out of 56 as a percentage, giving your answer correct to the nearest whole number. So that's just 18 divided by 56 times by 100. So 18 over 56 times by 100 gives us 32. That gives us 32.1428 ... So as a percentage, we're looking at 32% to the nearest whole number. Okay, question 20. We've got three people, Akhtar, Ben and Carl. Save some money. Akhtar has £65, Ben has 100, Carl has 3 £5 notes, 1 £20 note and some £10 notes. The mean amount of money of each person is £80. How many £10 notes does Carl have? Okay, so I'm going to do it like this. If their mean amount of those three people is at 80, it means that the total of their money is going to be 80 times by 3. So they've got a total of £240. If we think about it like this, A, B, and C, A has got 65, B has got 100, C has got 315, so 3 times 15, sorry, 3 times 5, 120, and some 10s. So I'm going to call that 10N. And then the total amount is equal to 240. So 65 plus 100 plus 35, I'll use my calculator, but I think that's going to be 200. 65 plus 100 plus 15 plus 20 is 200. So 200 plus 10N is equal to 240. So 10N is going to be equal to 40. So N is going to be equal to 4. He's got 4 £10 notes. Right, question 21. So for question 21, Malik is going to throw a fair coin 50 times. Write down an estimate for the number of times it will land on a head. So 50 times by 0.5, 25. Paul and Simon are trying to find out if a different coin is biased. Paula throws the coin 10 times. She records the number of times it lands on a head. Simon throws the coin 100 times. He records the number of times it's going to land on a head. Whose result is more useful in deciding if the coin is biased? That would be Simon's. Simon, as he did the experiment, because we're talking about experimental probabilities, did the task experiment, whatever you want to call it, I'll call it an experiment, more times. So the more time you do something, the more accurate it's going to be. Okay, and on to 22. Here is a solid made from a square base pyramid and a cube. Each edge of the solid is 6 centimeters. So each edge is 6 centimeters. On a centimeter grid, draw a plan. So the view from above. So the view from above, we're just going to see a 6 by 6 square. We would also see the diagonals. So in effect, the diagonal pyramid would create a cross. So obviously you're going to draw this with more care using a ruler, but that's going to be our plan, view from above. Okay, and question 23, simplify. So we're going to add the powers, so that's going to become n to the 8. For this one, divide, we subtract the powers, so that would be 3 take c, first of all. C to the power 3 take away 2 is 1, so c to the 1 or just c. D to the power 4 divided by d would become 4 minus 1, so that would be d to the 3. So c, d to the power 3. And then for part C, solve, we're going to get rid of the divide by 2 by times in by 2. We're treating an inequality just like an equation, so that would be 5x is greater than 14. Divide both sides by 5. That gives us x has to be greater than 14 over 5 would be fine. I'm going to go a bit further and say that that would be 2 4/5, or 2.8. That would also be fine. But like I said, 14 over 5 would be absolutely fine. We've just gone a bit more. Okay, question 24 then. So Andy cycles 30 kilometers at an average speed of 24 kilometers per hour. He then runs a distance of 12 kilometers at an average speed of 8 kilometers per hour. Work out the total time he takes in hours and minutes. Okay, so I'm going to treat it as hours first of all. So speed is equal to distance divided by time. So we are actually after time. So time is going to be equal to distance divided by speed. So for the cycle part, distance is 30 over 24, and to that I want to add the time for the cycle, which is going to be 12 divided by 8, and I can add it just like that as a fraction. So 30 over 24 plus 12 over 8, and that's going to give me, as a fraction, 11 over 4. As a mixed fraction, that's going to give me 3 3/4. 2 3/4. 2 3/4. And we should be at a point where we understand 3/4 of an hour is 75 minutes. 3/4 of an hour, a quarter of an hour is 15, so 3/4 is going to be 45. So 2 hours and 45 minutes. Okay, question 25. A number is rounded to 1 decimal place. The result is 9.4. What's the error interval? So it's been rounded to 9.4 as opposed to 9.3 or 9.5. So we're looking at the minimum value and the maximum value. So it's going to be 9.35 and the maximum would be 9.45. And that's all we need for our error interval. Nice, quite straightforward. 2 marks right near the end of a paper. Okay, question 26. Maisie knows that she needs 3 kilogram grass seed to make a rectangular lawn that is 5 by 9 meters. Grass seed is sold in 2 kilogram boxes. Maisie wants to make a rectangular lawn that is 10 by 14 meters. She has 5 boxes of grass. Has Maisie got enough grass seed to make a lawn 10 by 4? Okay, so I'm going to leave that second part of information and I'm going to just focus on this. So 3 kilograms is enough to cover a lawn that is 5 by 9. So the area of that would be 45 meters squared. So 3 kilograms will cover 45 meters squared, which means that 1 kilogram would cover 15 meters squared. And I'm going to use that. That's kind of my conversion that I will use later on in the question. So she's got a rectangular field that is 10 by 4. So so 10 by 4, sorry, 10 by 14. So 10 by 14 is going to be 140 meters squared. So the grass seed that she's got 5 boxes, and each box is 2 kilograms. So she's got enough to cover 5 times by 2. So she's got enough. She's got 10 kilograms of grass seed. So she's got enough to cover 150 meters squared. So has she got enough? So this is once. This is has. So does she have enough? Yes. Yes. She has enough. Maisie opens 5 of the box of grass seeds. She finds that 4 of the boxes contain 2 kilograms of seed. The other box contains 1 kilogram of seed. Does this affect whether Maisie has enough grass seed or not? Well, if we think about it, now she's not got 10. She's now got 9 kilograms of seed, and 9 kilograms of seed is enough to cover 9 times by 15. So it's enough to cover 135 meters squared. So does she have enough? No, she doesn't have enough now. So does that affect my answer? Yes, it does. Yes. She doesn't have enough now. She is 5 meters squared short now. Okay, question 27, really late on in the paper. In my mind, one of the easiest 2 marks that you'll come across on a paper. A lot of people kind of get to a sticking point and then think they can't do anything else. This is a real easy mark to pick up. So Amanda spins each spinner once. The probability of the tree diagrams. So spinner A, probability that it lands on a 2 is going to be 1 out of 3. So the probability it won't land on a 2, 2 out of 3. For the second spinner, same spinners really, 1/3, 2/3, 1/3, 2/3. That picks me up 2 marks. Really straightforward. Really straightforward. Okay, so in my mind, one of the easiest 2 marks on the paper. Then work out the probability that spinner A lands on a 2 and spinner A does not land on a 2. So I'm after a specific branch of this tree. Lands on a 2, does not land on a 2. So this is the branch that I'm after. So the probability of that branch then is going to be 1/3 times by 2/3, which would give me 2 out of 9. Okay, question 28 then. Use the graphs to solve the simultaneous equations. I think this is quite a nice question. So just double check that graph is the same as that graph. It does match. That one does match that one. So what we're looking for is the intercept of the 2 graphs, so where the 2 graphs cross. And then if you read off the x-coordinate is -2, and the y-coordinate is 4. So that's my point of intersection. So that's my that's my solution. The second one kind of leads on nicely from that. Find the graph. Use the graph to find an estimate for the solution to the quadratic equation. So we've got this as our equation. It does match. So in effect, what we want to do is find where this equation crosses the line y is equal to 0. Y is equal to 0 is this line here. So what I need to do is read off this coordinate and this coordinate, and those are my estimates for my solutions to x. So I'm going to say x is equal to, that looks like roughly, that looks like 0.6 to me, and this looks like 2.4. There we go. That's my solution. Yes, I've misread. That should be 3.4. Yeah, so 3.4. Okay, and next question. This is actually the final question, and this was not on the crossover. So this is kind of a foundation tier only. It's not a foundation tier only skill. It just wasn't on the crossover. Diagram shows a solid triangular prism. So the prism is made from wood with a density of 0.8 grams per centimeter cube. Work out the mass of the prism. So mass, density is equal to mass divided by volume. We can get a hint there. That's a measure of mass divided by a measure of volume. So we need to work out we want to work out the mass. So mass is equal to density times by volume. However, we have got the density, but we haven't got the volume. So we need to work out the volume of this prism. The volume of a prism is equal to the area of the cross section times by the length. So we need to work out the area of the triangle. The area of a triangle is equal to a half base times height. So that will be the cross-sectional area, and then we need to multiply that by, I don't really need that bracket, with it. So I don't really need that bracket. Let's see if I can do that, erasing everything else. And I need to times it by 10. So the volume of that then is going to be 0.5 times by 4 times by 6 times by 10. So the volume of that is going to be 120. So the mass of that object is going to be 0.8 times by 120. The mass is going to be 96. Look in the question for a hint of the unit. That would be grams. So 96 grams. And that brings us to the end of that paper. So it's quite a nice paper. This is a skills map for this paper, which is quite useful. So if you struggled on a particular question, and this will be chapter indexed in the video, if you're struggling on a particular area, you can get a little bit more direct revision around that area. It's also got quite this useful table. If you really look into it, it's interesting for me as a teacher. It gives you the mean score per question, mean percentage per question. It kind of tells you how many, the percentage of students, well, the mean percentage. So that suggests that the students found that on that paper, question 28, the most complicated. But that's quite a nice breakdown. But anyway, thank you very much for your time. Final thing before I go, for the November 2020 series. For the paper that we've just done, which was the 3F, those are your grade boundaries, 56 for a 5, 46 for a 4, 33 for a 3. Thank you very much for your time in listening. I hope you found it useful. Please feel free to add any questions, comments or feedback into the chat for the video, and I will get back to you fairly quickly. And if you found it useful, please do subscribe if you like.